Okay guys, here is 11.2, inference for two-way tables. We'll be using chi-square a lot. We'll be looking at a lot of the same material. It's a lot of the same format. It's just that depending on what is asked of us, we have to do a different test. So we'll be doing like independence, chi-square test for independence, chi-square test for homogeneous. We'll get to that one in a minute. All right, but the first thing we're going to do is we're going to review two-way tables, okay? We have a marginal distribution, which is these totals out here into these two totals here. So this is a marginal distribution. These two are also marginal distribution, depending on what we're asked to do. Okay, we did this way back in the good old days. Okay, so it'd be like, what's the proportion for marginal distribution? What's the proportion of males in this test? Would be 116 over 210. Okay. Conditional one was, we'd be saying, what's the probability of a sorry, got to make that capital P. The probability of ears pierced given that it is male. So that's telling us that our denominator is going to be 116, and then we look at the first part right here, and that's going to tell us that it's ears pierced, so then we would make it 35 over 116. That's our conditional probability or conditional distribution. Okay. All right. That's the main review. We've already done chi-square, so it's just going to be getting down to the brass tacks of what exactly do they want us to do. Okay. All right. So we've got this example here. I've already written out the questions and everything like this. So this is birthdays. The question is, has modern technology changed the distribution of birthdays, with more babies being delivered by planned C-section? Miss McDonald's statistic class hypothesized that the day of the week distribution for births would be different for people born after 1993, so like you guys, compared to people born before 1980, me. After all, why would a doctor plan a C-section for the weekend? To investigate, they selected a random sample of people from each of the two age categories and record the day of the week on which they were born. The results are shown in the table. Is there convincing evidence that the distribution of birthdays has changed? So I put the table on the next sheet of notes so that I could get the questions down, and then I can show you that page here in just a second. All right, so our questions are, calculate the conditional distribution and proportion. So we're going to do this in fractions and decimals, okay, of the birthday for the older people, me, and younger people, you. Make an appropriate graph for comparing the conditional distribution. So we can either do a bar graph. We can probably get away with doing a pie chart, but I think that would be more confusing, just because of trying to get the data to match up and comparing it to others. Bye, Chloe. And so the histogram, we're not looking for outliers, so I'm not going to worry about the histogram. Not histogram, box plot. And then the histogram, the data is not connected, so we're probably going to be looking at probably at the bar graph. Okay, and then we're going to write a few sentences comparing the distribution of birthdays for each age group. All right, so here's our table. I'll read the numbers, make sure you can read it. Before 1980, Sunday is 12, Monday is 12, Tuesday's 14, Wednesday's 12, Thursday's 7, Friday's 9, Saturday's 11. After 1993, Sunday's 9, Monday's 11, Tuesday's 11, Wednesday's 10, Thursday's 17, Friday's 9, Saturday is 6, for a total of 73. Total here is 77. Then this is 21, 23, 25, 22, 24, 18, 17, and 150. 21. Okay, so now question A, if we go back to here real quick, it says calculate the conditional distribution of the birthday for older people and younger people. So what I did is I left us a little space so that you can kind of see what we're going to do. So what I'm going to do is I'm going to take the 12 divided by 77. I'm going to go 4 places. Okay, so that takes care of that one. And then over here, I'll come over and do the same thing. Let's see, 11 divided by 73. 71507. 10 divided by 73. 3. Because of the rounding, that's what that one becomes, because this was 698, so the 8 would round the 9 and would go up, obviously. I don't need to explain rounding to you guys, do I? I hope not. It's been one of those weeks. So, we're going to have 2, 3, 2, 9. We're going to have 9 divided by 73. I'm just going to write the last 2 just like that. So 9 divided by 73. 1, 2, 3, 3. And then we're going to go 6 divided by, oh, I could have just used that one up there. Sorry. 0.0822. All right, so that takes care of my A. I'm going to pause it and make my, I'm going to make a bar graph. I'll show you real quick intermediate so you can kind of see where I'm going with it. So let me get started. Okay, so here is the beginning of my bar graph. I've got the percentages up in here. So I've gone from 0.25, 0.20, 0.15, 0.1, and then 0.05. Down here I have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. I'm going to choose 2 different colors. I don't want similar colors, so I'm probably going to do red and green. I'll probably do red and black just to kind of go with there. So I'm going to make the older guys. So I got 0.15, so I'm going to go to 0.16. So I'm going to do, remember on Sunday, I'm going to try and make it look really nice for you guys. So I'm going to go up to here, a little bit above it, and then I'm going to come over here, and then I'm just going to drop it right down, just like that. And then I look over on the after. I know you guys can't see it right now, but there's 0.12. So I'm going to do my best to kind of eyeball it in there. And then there's that. So that takes care of before and after. So I'm going to pause it here, finish up my bar graph, and then we can go to the next. All right, so here is my bar graph completed. I came through and I did do a little bit of shifting on my labels because it wasn't matching up, and I figured I'd try to make it look nice for you guys. So the next part says that we are asked to write a couple sentences about what we see. Well, I see that there's a larger proportion of people born on Thursday, so I'd come up to here and say there is a larger proportion of people, probably population born on Thursday in the after 1993 age group. If I look at the before 1980, it seems pretty flowy. The before 1980 age group seems to be fairly consistent. With a low on Thursday at 0.0909, and the highest is on Tuesday at 0.1818. But you know, if we look on the weekend, there's 0.08 on Saturday, 0.14. That's a pretty significant difference. Saturday. Oh, you guys can't see. I've been covering it up. Saturday had a difference. On the proportions. So there's that. There's our first video. That's the first 2 pages. We got 9 more. 9 more. Okay.